welcome to this Neptune CFD pool boiling tutorial. We will be simulating the evaporation of water in the bottom of a rectangular pool thanks to a heat source. It's going to be a two-dimensional domain. So first of all, you need to create a study called pool boiling with a case. Then go in the pool boiling directory, case 1 data, and launch the shell script Neptune CFD to launch the graphical user interface. For this tutorial, we will be generating our mesh by clicking on Generate Cartesian Mesh. So create a mesh with 100 cells in the X direction, in the Y direction with a length of 1 meter, and 1 cell in the Z direction with a length of 1 centimeter. You can check your mesh properties by changing the execution mode to mesh preprocessing only. Then go in your residue directory and display the listing. You can check the domain length and the number of cells. Then switch back the execution mode to standard computation. Then click on volume zones and add a new zone called AC with the following selection criteria. So this is a square with a length of 10 centimeters. Then on boundary zones, add a first boundary condition called outlet with the following selection criteria. Then a second one called walls. It will represent the bottom and the domain sides. Then add a last one called 2D sim. It will be the symmetries in the Z direction. On calculation features, check Eulerian multiphase with the multi-regime liquid gas flow and click on yes. And don't forget to activate heat and mass transfer. On main fields, change the field label for water and gas. In this case, both fields are compressible. For the turbulence models, choose the following turbulence model for the water field. And for the faces coupling, choose separate faces. Then add a body force in the Y component for the gravity. Then you will need to add a non-condensable gas called R2. Then click on closure modeling. For the water-gas interaction, let the following properties. Then click on interfacial area. For the water field, a constant model with a 1 mm default diameter is used. And for the gas field, the interfacial area transport model is used with a default diameter of 1 mm. Then click on interfacial enthalpy transfer. The different parameters are already set, but you need to check Activate Pool Boiling Evaporation Model. Then click on Wall Transfer Parameters and choose the Nucleate Boiling for the wall transfer type. On volume conditions, check initialization for all cells. And for the AC zone, check porosity, head losses, and thermal source term. So first click on all cells. The thermodynamic properties are set with the Qatar method. So click on the initialization tab. For the pressure, we will set the hydrodynamic pressure. So set the following expression. So if y is lower than 0.8, set the hydrodynamic pressure. And else, set the pressure of 1 atmosphere. So initially there's no velocity. And for the volumic fraction of water, set the following expression. If y is lower than 0.8, set a volumic fraction of 1, and else set a volumic fraction of 0. And for the temperature, set the following initial value. Then for the gas field, initially there's no velocity. For the volumic fraction, if y is greater than 0.8, set a volumic fraction of 1. And else, set a volumic fraction of 0. Set the same initial temperature as for the water field. And for the non-condensable gas, set the following expression. If y is greater than 0.8, set a volumic fraction of 1, and else set a volumic fraction of 0. So this is all the air which is above the water. Then click on AC. First, for the porosity, set a value of 0.6. For the head losses, set a value of 200 for the 3 fields. And in the source terms tab, set the following properties for the water field. And for the gas field, let the values as 0. And then on boundary conditions, change the different natures. So first for the outlet. So the outlet is located at the top of the domain, so there's no water. And for the gas, set a fraction of 1. For the walls, set a constant temperature of 293.15 kelvins. Then on time settings, set an adaptive time step with a reference time step of 5 milliseconds and a time analysis of 100 seconds. You can then change the maximum current number for both fields to the value 2. For the numerical parameters, uncheck Activate Reconstructions, and no need to change anything for the pressure. Click on Post-Processing and set an output listing every time steps. Then on the Writer tab, set an output every 0.5 seconds. Then click on Volume Solution Control and check the R2 for the post-processing, so you can post-process the results of the non-condensable gas. Then save the simulation and launch the calculation. You can then post-process the results using PowerView. We can display the volumic fraction of water, and we can see the water evaporation.